Hi everyone, welcome to the next set of videos for the next section of the book. So the first thing we want to do is talk about basic terminology for functions. So this is mostly a bunch of definitions and what they mean, and I have a graph here to demonstrate some of the concepts. So remember that any point in the plane can be represented by some x-coordinate and some y-coordinate. And in particular, if you have a function graphed on the xy plane, all the points on the graph are going to consider of an x point, but the y-coordinate is going to be the value of x evaluated under the function. So instead of y, we write f of x. And remember that sometimes we do actually say that y equals f of x. So this is the type of substitution we're making here to get this point here. So every point on this graph, this point, that point, that point, all of them are of this form x, f of x. So there are certain points that are more important than each other, so that's what we're going to talk about. But two quick definitions here first. These are called coordinates of the ordered pairs. So this is known as the x-coordinate, and this is known as the y-coordinate. So notice that the x-coordinate always corresponds to the independent variable, and the y-coordinate always corresponds to the independent variable. And actually that doesn't even, that terminology still holds if we just look at an arbitrary point in the plane that is in the graph. This is still called the y-coordinate. It is just not on the graph of the function. Now, we're going to mostly be concerned with points on the graph of the function, and there are certain ones that are important. So let me get rid of these kind of, oops, better not have done that. So let's bring that back. So we'll just leave them where they are so we don't do that again. And so there are certain points that are more important than others. One of the most important are where we cross the x-axis. So let's label our axes, x and y. And these points right here are known as the x-intercept. And one of the things we know about the x-intercept is, notice that in particular for this one, if we're to the left of it, we're going to have negative values, and to here we're going to have positive values. And then again we're going to switch and have negative values, and again we're going to switch here and make positive values. Now that doesn't always happen. We could have a graph that does something like this. So we draw something like this, and while we have an x-intercept here and an x-intercept here, notice that there's a sign change here, but here we're going to be negative and not have a sign change. So notice that potential sign changes in your function occur at the x-intercepts. Now, a big deal I do make about intercepts that intercepts are points. And so a lot of times, particularly this comes up with graphs of lines, is that you look for an intercept and you give me the value of b instead of the point of the that corresponds to that value of b. So remember that all your x-intercepts are going to look like x comma 0. Notice that in both of these pictures I could have multiple x-intercepts. So here I had 3 x-intercepts. Down here I had 2 x-intercepts. And you can actually even have 0 x-intercepts. So we can draw an easy picture of that. An easy one is just a parabola that does not cross the x-axis at all. So 0 x-intercepts. So basically, you can have anything from 0 to as many x-intercepts as you want. The other x-intercepts also go by another name, x-intercept. Well, maybe not quite. This is not quite the same thing. X-intercepts correspond to real zeros of the function. So what is this real zero? So let's look at some function f of x equals x squared plus, or let's make it minus 2x plus 1. And so if I plug 1 into this equation, we see that f of 1 equals 1 squared minus 2 times 1 times 1, and this will equal 0. And so this says that x equals 1 is a real zero of f of x equals x squared minus 2x plus 1. And so notice that real zeros are always x equals. And that's because these are values, when we substitute them in to the function, we get a 0 as our value. While the x-intercept it corresponds to is the point 1, which is what we plugged in. It's a crappy arrow. Comma 0, which is the result we get. So if I'm looking for a 0, I'm looking for something like x equals. When I'm looking for an intercept, I am always looking for a point. So be careful of that distinction. Now, the last thing we want to talk about is the y-intercept. And so let's draw a new graph here. So let's make something a little bit different than what we've been seeing before. So again, I'm mostly using polynomials to represent our graphs. And this point right here where we cross the y-axis, this is known as the y-intercept. And again, the y-intercept is a point, and it's always going to look like 0 comma some value of y. So notice that x-intercepts have y equal to 0. Y-intercepts have x equal to 0. So I always like to think that if you're looking for a y-intercept, then you set the opposite variable equal to 0. While you're looking for an x-intercept, then you set the opposite variable y, in this case, equal to 0. Finding the y-intercept depends on the type of well, actually, it doesn't really depend on anything. It actually just to find the y-intercept. You just have to calculate something very simple. F of 0. And then the y-intercept is, so this just gives you a number. So the y-intercept is a point, so the y-intercept is equal to 0 comma f of 0. Now, not all functions have a y-intercept. For example, y equals 1 over x does not have a y-intercept, because when we draw this, we get these two parts of a hyperbola here. And notice that it will never intersect the x or y axes. So this has no y-intercept. But notice when you, because of the nature of the vertical line test, notice that if you have a y-intercept, you have only one. So for y-intercepts, you can have 0 or 1 only. Which is in contrast to the x-intercepts, where you can have 0, 1, 2, 3, 4, and as many as you like if you're designing the function. So this is some of the basic definitions. So the next section is to go about finding real zeros with the TI-84, and I'll see you then.